And I'm back. So, what did we just learn by watching that music video on angles? We have 4 types. There are 4 types of angles that we have to know and pay attention to. We have acute angles, like Baby Shark. They're teeny, teeny, tiny. That's why we call them acute. They're acute angle, little angles. And then we have 90-degree angles, look like the loser, double loser signs, and they make a square. 90-degree angles are a corner of a square. It looks like an L. Okay. Then we have obtuse angles, and they're really, really big. They are bigger than 90. And then we have straight angles, and those are 180 degrees. If we can remember those 4 angles, or those 4 types, we can learn all about rotations. So, what we're going to do is we're going to look at what rotating an object looks like. So in this case, we're going to rotate triangle ABC 90 degrees clockwise. What direction is that? If you said to the right, you're right. We're going to do that about point O. Point O would be our center of rotation. And we're going to produce the following image. A 90-degree turn, that's a quarter turn, makes an L shape. And spinning. Perfect. Notice, the triangle is still the same. It didn't get bigger and it didn't get smaller. What happens? What do we call it if a triangle stays the same after a spin or a rotation? If you said congruent, you're right. Congruent means same shape, same size. And that's why we call them rigid transformations. That's why a rotation is a rigid transformation. It doesn't change the shape, and it doesn't change the size. Sometimes the center of rotation can actually be inside of the object. So we're going to rotate this object 90 degrees counterclockwise, about point 0, or point O. I'm going to move myself so we can see. Counterclockwise. What direction is that? If you said to the left, you're right. 90 degrees, quarter turn, makes a square, corner of a square, and spinning perfectly. Excellent. We're going to look at rotating shapes on a grid. So the vertices of triangle ABC lie on the points 2, 6. So notice we go X, then Y, 2, 6, 7, 3, over 7, that's my X-axis, up 3, that's my Y-axis, and 4, negative 1, over 4, that's my X-axis, and down 1, that's my Y-axis. I'm going to move myself again so we can read the directions. We're going to rotate the triangle 180 degrees counterclockwise, so that's our left, about the origin. And then we're going to label our points. Where is the origin on the graph? What are the points for the origin on the graph? If you said the origin of the graph is in the center, and you said those points are 0, 0, you're right. And we spun 180 degrees, or 2 paper turns. It looks like it made a straight line, half of a circle. Our new points are at negative 2, negative 6, negative 7, negative 3, and negative 4, 1. Moving myself again. What do you notice about the point and its image? What do you notice about the old points and the new points? What do they have in common? What is different about them? We're moving again. Let's look at the next image. Okay. The vertices of this triangle lay on the points negative 7, negative 6, So remember, we go x and then y, negative 4 and 2, x and then y, and negative 4, negative 4, x and then y. And we're going to rotate the triangle 90 degrees clockwise. That's our right. About the origin, which we just learned is the center of the graph, right here in the center. And then we're going to label our points. Wait, we're going to see that spin one more time. And spin. 90-degree turn. What do you notice about each point, the old points, and now the new points? Our new point at A is negative 6, 7. Our new point at B is positive 2, 4. And our new point at C is negative 4, 4. What do they have in common with the old points? And what's different about them? And that's it, guys. So, just to recap this week, I'll make myself bigger. Awesome. Just to recap this week, we went over all of our rigid transformations. So that was reflections, that's a mirror image that makes something flip. We went over translations, that's a slide, left, right, up, or down. And then rotations, that's a spin. And these are called rigid transformations because they do not change the size or the shape of an object. So every rigid transformation makes the old image and the new image congruent. Okay, that's it.